Oh, so we need to wait for some time. Pencil somehow is not charged. So let me try with my fingers. So this question says the values of the device parameters are given. The threshold voltage is 1 volt. kW by L is 2 milliampere and channel modulation is 0.01. Characteristic capacitances CGS and CGD are given. And the other parameters are, so these are the resistance and some external capacitance parameters given to us. And VDD is 10 volts. Find the transconductance of this transistor as shown in figure. So, okay, so for the transistor, we know IDS is kW/L GS minus VTH whole square. Okay, I guess we should wait for a few minutes till the pencil gets charged for some time. Then we can start again. Otherwise, these will be the large letters. Let me just erase it and we should wait for a few seconds. Yeah, I guess this is okay. And we know the current. This is IDS. So I can write IDS as IDS RL. That means IDS can be written as VS by RL. So why do we need that? VGS is VGS is VG minus VS. So there we can use this. VG. What is VG? R2 by R1 plus R2 times VDD minus VS minus VDH whole square. Right? I guess we have done this question in the previous week. So let me just directly write. So this will be 1 second. How much is this? 12. Okay, this is sufficient. So what we can do is we get an equation of this type. 2s square minus 17s plus 32 is equal to 0. And we found out that Vs is 2.1 volt. And GM is 2 milli times VGS minus VTH, that was around 2 point. We need to watch the previous session where we explain these things. I'm just writing the values because we need in few questions. Okay, so this was the answer for GM. Just note it down when you need it. And the voltage gain, for which I drew the equivalent circuit. So I have the output node, that is this one. You can write. Okay, so we have solved this in the previous session. Please watch the session and you will get V naught by V in as GM. So this is how we calculate for V naught. So what we didn't do in the previous session was this part. Find the upper cutoff frequency of gain V naught by V in. We need to find this. We need to find upper cutoff frequency. So what we will do is, since CGS parasitic given, that is CGS and CGT, so total output capacitance will be given by load capacitance plus Miller capacitance. A, which will be given by V naught by Vn, we will equate it, and it will come out to be 0.82, should be minus, then we will calculate C effective out, and also let me give you the formula for C input effective, that will be CGD times 1 minus A. Now, what are the cutoff frequencies? Let's say FC1, which will be given by 1 by 2 pi C input, R1 parallel R2. I want you to calculate it if you are watching the video. Find these values, and second one, that will be given by that will give us upper cutoff frequency. It will be C effective out multiplied by R. It is the R here, 1 divided by 1 by RL plus 1 by R1 AGM. This R is the total resistance seen by this capacitor. So, what are the steps you need to do? One, you need to find C effective, and then you need to find R, and for which you need to find RL is good, R naught and GM. GM we calculated. You just need to find R naught, which will be given by 1 by lambda ID. And for that, you have ID value, lambda is given. You can find R naught and then find the R divided by the upper cutoff frequency. Okay. Just 1 second. We'll check whether I need to show anything else in this picture. Okay, let me just show this. Okay, how we calculate the equation. So basically, we have an equivalent circuit of this type. So this capacitance will have some of its part as the input and some of the other part as the output, right? For this, we need to calculate the R. How will you calculate that? Just add a test source here, which is Vx and Ix, and other sources will be grounded. So basically, your Ix will be Vx by RL plus Ix is the current going in, okay, plus this will be Gm VGS. This is going like this. This will be GMVX. So it will be in the opposite direction. So it will be GMVX plus Vx by R naught, which is here. Vx by R naught. So Vx will be common. This will be 1 by Rn plus 1 by R naught plus Gm is equivalent to Ix. So Vx by Ix will be equivalent to 1 divided by 1 by Rn plus 1 by R naught. So this is the resistance which will need to calculate the effective, output. And for this case, for upper cutoff frequency, you will need this formula, not the one which I showed earlier. So you will have this R multiplied by CL. Use this formula to calculate the upper cutoff. Okay, so moving on. You have this transistor. The circuit shown in figure is a common gate amplifier. Common gate is usually used for such applications. It is like this. For example, you have this knob here, this gate, and you have drain here, you have source here. So a signal passes through drain to source when there is a channel here. Okay, so this is a common gate. That means this is a DC biased and an AC signal is supplied to drain to source. Okay, so when transistor is off, let me just note it as TX. TX is off. AC signal does not pass. When TX is on, AC passes. Okay, so this acts as a switch between the two nodes. So what we need to do is find the value of small signal parameter output resistance RDS. Okay. We need to find RDS or R naught, or our aim is to find R naught, and for R naught we need to find IDS. right? Since this is a PMOS, so that is ISD. So what is the formula? ISD is KW by 2L USG minus VTHP whole square. And if you look here, what is VG? This is gate terminal. So my VG will be R2 divided by R1 plus R2 multiplied by VDD. Okay. So my VG R2 divided by R1 plus R2 multiplied by VDD. So this is R2 20, R1 is 50. This is 20 kilo ohm divided by 50 kilo ohm plus 20 kilo ohm multiplied by 12. That's VDD. So it comes out to be 4 volt. And Vs is 12 minus ISD RS1. How? Here, this is ISD, so this is my Vs, simple Ohm's law. So I can write ISD as 12 minus Vs by RS1. So substituting it here, we will get a quadratic equation and Vs comes out to be 6.64. And this means VSD should be greater than or equal to VSG minus VTHP. ISD is equivalent to 12 minus 6.64 from this equation by RS1 comes out to be 0.6. So now we have ISD. I can write R naught, which is what the question said, to calculate as lambda ISD, which is 1 divided by 0.01 multiplied by 2.68 milli, which comes out to be 300. Sorry, let me just put it. 37.3 kilo ohm. So this is the answer. Very basic. Next is find the voltage to current line. This is different. We need to find the output by IN. So what we usually used to do, we used to find V output by V in, that is voltage gain. So V output by V in. And what is I out by V in? Transconductance, right? Okay. So hint is the output by I in, we can calculate it from AI multiplied by R naught, where AI is I output by I input. Okay, so I output multiplied by R output is equal to V output. So we need to find the current gain of the amplifier, and R naught is the output resistance. So this makes our solution easier. Okay, let us draw equivalent circuit. So let's look at the circuit. This is our circuit. When we go on to draw the equivalent circuit, what we'll have, see here, I input is here. That means the other terminals will be grounded. So we will have gate as grounded. So our gate will be grounded. And in the source, we will have I input with source resistance of RS1, and this will again be GM times VGS. This is R0, this will be RD. Let's look again. This is our VR. So if we take KCL at this node, so we can write V output by RD plus V output by R0 plus GMVGS is equal to 0. Okay. Vg is 0, so it will be GMVS is equal to 0. Right? Also, if we check this node, let me call this A, let me call this B. At B, we have I in. These are the currents coming in is equivalent to Vs1 by Rs1. We are assuming a current this direction, this in this direction, and this is leaving like this. So we are assuming this. So we will have this as KCLN. So I in comes out to be, this is minus GMVS. So it will go here as a positive. So it will be GM 1 by RS plus 1 by R0 times Vs. Okay, so this is In. Also, let's say this is, sorry, this is I out here. So for I out, what we can write here is, see here, I out is simply this potential is Vs. So the current leaving, and check it. Wait a second. So if I assume the current of I out flowing like this, so it will have basically I out. I will get this. Okay. So now if I have to calculate the current gain, let me take the magnitude to be I output by I input. So this will be Vs GM and by R naught whole divided by I input, which is again in terms of Vs as GM plus 1 by Rs plus 1 by R naught, correct? So Vs and Vs will cancel. So this implies current gain I output by I input is equivalent to GM by R naught divided by GM plus. So therefore, V output by I input is equivalent to I output multiplied by R output divided by I. So I just need to calculate R out. So this is my realistic argument. Let's assume that the source Vx and current of Ix. So basically now Ix is equivalent to Gm Vgs plus Vx minus this is at a potential of Vs by R naught. Use it. So let's solve this. Vs will be here the current coming in is Ix, so the leaving should also be Ix. So Vs is Ix Rs1. So this implies Ix. So this should be Gx because Vg is 0, Vs is Vx. Sorry, Vs. This is Vs plus Vx by R naught plus Vs by R naught. Substituting Ix Rs1 for Vs, we can get Ix plus GM IX RS1 plus IX RS1 by R naught is equivalent to Vx by R naught. Taking IX is common, so this is GM RS1 plus RS1 by R naught plus 1 is equivalent to Vx by R naught. So Vx by Ix is R naught times 1 plus GM RS1 plus RS1 by R naught. So this is my R out dash. This is my R out dash. And now total R out will be R out dash in parallel to RD. So this is my total R. No, I should not use RD because this is both grounds attached to it, so it will have no effect. This is my total R out. Let me just know plus RS1 plus GM R not RS1. So therefore, we output by V in sorry, AI, which is current gain multiplied by I. Okay, so you can take the values and calculate it. We need to find the upper cut of frequency of this. Okay, so we have poles such as 2 pi, C out, R out, and another pole will be under 2 pi, R1 parallel R2, sorry, RS parallel RS, C in. R out, if you check the previous question, R out will be equivalent to 2 kilo. Use that formula to calculate that. And here C input is also equal to CGS. For this question, you can use this equivalent circuit to solve it. Okay, so use the circuit to calculate. See here, RS1 is equal to RS. If you are calculating for C input, and similarly for output, we calculated the output resistance in the previous part. Use that. Okay, so now moving on to this machine. So the circuit uh, is is a common source, common drain amplifier. Okay, so this is a cascade system. The values of the device parameters for the both transistors are given. Channel length modulation is 0. The values of the components in the amplifier are given. Okay. The values of parasitic capacitances of transistor M2. This is our M2 transistor. And that is CGS is 10 picofarad and CGD is 5. Assume the parasitic. Okay. For M1, it's negligible. Find the DC voltage V out between the source of M2. So this is the NMOS. So this is source of M1. Okay, source of M2. That is this one. This is source. Drain, drain, source. Let's call it D1 S1, D2 S2, and this is J2, and this is G1. Sorry. 1 second. This is not NMOS. This is a PMOS. So this will be my source line. Okay. So this is how my source and drain terminals will be. And this is the out. We need to calculate a DC voltage. Let's start first. This VG1, that is a gate bias for transistor M1. Simply, that is R2 divided by R1 plus R2 multiplied by VDD. Simple voltage divider. R2 is 12K divided by R1 is 4K plus 12K multiplied by VDD. VDD is 12 volt. So this is 12 by 16 multiplied by 12. It is 9 volt. So basically, VSG1, because we are interested in VSG1, that will be 12 minus 9, which is 3 volt. So now we have VSG1. We can calculate ISD1 as KW by 2L VSG1 minus VTH whole square. So ISD1 kW by this 1 milli. So this is 1 milli by 2 multiplied by 3 minus 1. VTH is 1. Magnitude is 1. So it will be 4 milli by 2. It is 2 milli. So this is the current flowing through the transistor. Now VG2. What is VG2 here? VG2 is simply the potential drop across the drain, or VD1, that is the potential drop across R3, right? So that is ISD1 multiplied by R3, which is again equivalent to VD1. So I can write it as 2 milliampere multiplied by R3. R3 is 4 kilo ohm. So this is 8 volt. So now I can calculate ISD2 as kW by 2L VSG2 minus VTHP whole square. Now look here, we don't know what is the VS. VS for transistor 2. So for that, we will use Ohm's law, which gives us VDD minus VS2 divided by R4 as ISD2. Okay, so we will use this equation here with this equation, and we will get a quadratic equation, and finally we will solve. Okay, so now I can write VDD minus VS2 divided by R4 is equivalent to greater than the L VSG2 minus VTHP whole square. Just simplifying the equations, we will get two values for VS2 will be 10.65 volt and 5.35, and out of which you know how to check which one is the correct. You need to do that yourself. So this will be my answer. Please do it yourself why this will be the answer. This is 10.65, and which was actually required as well in the question. So the output is, therefore the output, which is equivalent to VS2, is 10.65. This is my DC output voltage. Okay, we have just few more questions. Now we have to find the small signal output resistance for the circuit, and we know for that we need to draw the equivalent circuit. So we need to draw the equivalent circuit for this figure. Okay, Let's draw first for the M1, which is simple. Since we need to find the output resistance, so we go ground. So if it goes to ground, we don't really need the input. So this is all equivalent to zero, which in VGS will also be equal to zero, but I'm drawing for understanding, so it will be easier to understand. This is again gate 2, which is D1, G1, S1. Okay, this is a test source connected. It is Vx. I actually calculate the resistance. So this is VGS2. This is, okay, and now you can calculate it, right? Let's take this node. So it will have G of VGS2 plus Ix is equivalent to Vx by R4. Simply, Vg is 0, Vg2 is 0. So it boils down to minus G of Vx plus Ix is equivalent to Vx by R4. So Ix will be Vx by the common R4 plus Gm, and thus R, which is Vx by Ix, will be equivalent to 1 by R4 plus Gm. Okay? But this is general law. This is for the transistor. Now, what is your assignment for you is to calculate Gm flow. Can you do it? Just use the formula. Don't scare. Now you know everything for this equation. You know Vs, you know Vg2. You can calculate Gm2 as Kw by L Vs G2 minus mod of VTHP. Okay, you can calculate it. Calculate the value and get the answer. Just let it charge for 2 minutes. You can skip the video for that part. Okay, so let's change a bit. Okay, so we need to find the voltage gain and mid frequency. Okay, so whenever it is mentioned the mid frequency, find the normal gain of the transistor. Okay. So for M1, V input is VG1. Okay, so V input is directly VG1, and what is VG2? Let's say this is its output. So I can write, so this is first part. So if this GM is GM1, so across R3, that is a drain terminal, so that is VD1, which will be VG2. So it will be given by GM1 R3. GM1 R3 is the current flowing. Sorry, GM1 into V1. V input is the current flowing through the transistor. So GM1 multiplied by R3 multiplied by Vn will be the potential across this resistor. Okay, so you need to calculate a few things and you need to calculate G1 on your own. So that's simple. R3 is given. I will just write it. GM1 R3 is equal to 8. And now, if I look at this equivalent circuit, and assume the current flow in this way, so I can write V0 by R4 is equivalent to, look here, the current flowing is GM2 VGS2. So V0 is R4 GM2 VG minus V0, VG2 minus V0. So V0 plus R4 GM2 V0 is R4 GM2 VG2. So this is V0 1 plus GM2 R4 is equivalent to GM2 R4 VG2. Okay. So this is V0 is equivalent to GM2 R4 divided by 1 plus GM2 R4 VG2. However, we calculated in the previous step as VG2 is GM1 R3 V input. So therefore, V0 by V input is equivalent to GM2 GM1 R3 R4 divided by 1 plus GM2 R4. This will be your final answer. For the values that are simple, you just can calculate it. Okay, and cascade system, we can always use this formula, gain as AV1 multiplied by AV. Okay, now we need to find upper cutoff frequency. Again, for the circuit, and total output resistance multiplied by load load capacitance in the denominator, and you can have another upper cutoff frequency with respect to not upper cutoff frequency. You just need to calculate both the frequencies to check which one is the upper cutoff. These are the two poles. We need to calculate it. Finally, what is the amplitude of output signal for input signal? So, where V output is total gain multiplied by V input. So, this is the total gain equation, and we calculated it in the previous step. So, the input is 120 millivolts peak to peak. So, that means the output will be AV total multiplied by V. Sorry, let me just put the value. Millivolt. And I have not calculated AV total in the previous step, but AV total, let me just give you the value, comes out to be 5. But you need to calculate it in the previous step, just substitute the values. So this will be around, and, sorry, 5. Okay, so in this part, we again did somehow the same exercise. And it should be quite easier now to calculate or first draw the equivalent circuit, then calculate the upper cutoff frequencies and how to calculate gain. And we also looked at in this session how we can draw the equivalent circuit for cascade and derive its values. So I guess that's it for today's session. And in next session we will also look at something related to small signal analysis. A little bit complex circuits. We will look at some cascode systems as well. Yes. So, okay, let's move next.